Let M be the vector space of all 2 by 2 matrices and define T from M to M by T of A equals A plus AT, where A is given by this matrix. So this is T of input matrix equals input matrix plus its transpose. And where that input matrix is, by the way, just a 2 by 2 generic ABCD. In part A, we need to show that T is a linear transformation. Okay, so for this one, we need to show two things. Okay, T of A plus B, okay, sum of two matrices, that should be same as sum of transformation. Okay, transformation of sum equals sum of transformations. That's what we need to show. Okay, so let's work into this. So for all A and B coming from the domain, T of A plus B is, now from this definition, T of input is equal to input plus input raised to transpose. Okay, that is coming from the definition of this transformation. T of input equals input plus input transpose. So here now we can rearrange. This is A plus B. Let's transpose of this sum. We can simply compute AT plus BT. Now we can rearrange A plus AT. Let me put them together. Plus B plus BT. And the first is in fact same as T of A plus, and this one is T of B. Okay, so we showed that this T of sum is sum of transposes. And next we need to show for all A and for all constant C, T of some constant A equals, now T of input is from this definition, input plus input transpose, but this C is a constant, so it just pulls outside, and AT is just AT. From these two we can pull C out, A plus AT, and the C, this is in fact just T of A. Okay, T of A is A plus AT. So we showed that T of scalar product is just a scalar product of transposes. Okay, this one is for all. I need to write down, okay, somewhere. Okay, for all C in R. So at the beginning, I need to write down for all A and B coming from the domain M22. For all, this is true. So this shows that T is a linear transformation. Okay, let's do part B. In part B, it asks, let B be any element of M22 such that B transpose equals B. Find an A. So we need to find one A in M22 such that T of A equals B. So this A is in domain, by the way, and this B is in the range. So we need to find one A. So pretty much T of what equals B, and this B has property B transpose equals B. That's given. Okay, if we look at the definition how T is defined here, this is in fact T of input equals input plus input transpose. Okay, so T of input, that's what we are trying to find. That would be that, I'm just writing anything, plus that transpose equals B, and our trying to find what is this. So there will be sum of two matrices equals B. And let's take this unknown, that's a, find a, is sum of 2 equals b. Let's take that equals half of b. Okay, then half of b plus half of b would be hopefully just a b. Okay, let's try that. So we need to find a. Okay, if you read the question here, find an a such that t of a equals b. So let's take that a. Let a be half of b. Now it's given that then t of a equals b implies, so we are trying to determine a, and I am assuming that's 1/2 b. Let's see if this works. So t of a from the definition is this one, because our a is now half b. Let me write down, or t of half b equals b. We need to show this should be true. Okay, then our answer a half b works. T of input from the definition is input plus input transpose equals b. Let's see, this is half b plus half b transpose, half outside just comes outside, b transpose equals b, half b plus half b transpose. So in part b it's given that b transpose equals b. So this is half b equals b. So half b plus half b equals b. That's true. So we are supposed to find one, okay, find an a such that ta equals b, and we chose a equals 1/2 b, and that worked out. So the answer is 1/2 b. Okay, for this one. So let me go a little bit down here. Okay. Now let's do part C. So that's maybe we're gonna write down thus a equals half of b. Okay. In part C, show that the range of t is the set B with the property bt equals b. Okay, so the range has the property, so range contains all b with b transpose equals b. From part B we saw that the range, okay, the b has the property here, so we showed that range of t contains all the set in B, all the set B in M22 such that B transpose equals B. We showed halfway kind of, okay. So let me that, so it's kind of a halfway done. Part B shows that the range of T contains B in M22 such that B transpose equals B. Okay, what we need to show here is, next we need to show that's just for 1A. Okay, we choose A equals 1/2 B and we showed that. We need to show that any B in the range of T has this property. For 1B we saw that happened, but we need to show any B in the range of T has this property. Okay, that means B transpose equals B. Okay, so then we start with T equals B, so B equals T of A. Okay, that's in T of A equals B for some A in M22. Okay, then T of A equals B, we assume that is true for A in M22, and we want to show that this B has the property B transpose equals B. Okay, then TA equals B means, what is the definition of TA? TA is A plus AT. Okay, now we need to show BT equals B means let's find the transpose of this one. Now if we find the transpose of B, that means A plus AT transpose, which is A transpose plus A transpose transpose, which is A, we can write in this way, and this one is A plus AT equals B. Okay, what did we prove now? So any B has the desired property. We wanted any B raised to T, any B transpose equals B, so B has the desired property, or property such that when we transpose it comes out to B. Okay, that means we proved part C. The range of T contains all the B with B transpose equals B. Okay, so the next describe the kernel of T. Kernel means we need to find all A that are mapped to the 0 element of codomain. So part D. So we need to find describe means we said TA equals 0. Okay, 0 matrix by the way, and which is also we can call a vector. TA equals 0, and what is A? I mean that's what we are doing. Okay, describe the kernel. Yeah, and here this is the question. We are given that A is just A, B, C, D. Yes, we are given in the question. Okay, so we said T of A equals 0. Okay, that means T of A is in fact A plus A transpose equals 0. And now A is ABCD. Let me put it this way. So A is ABCD. A transpose will be what then? ABCD equals 0. If we add these two, then this will be A plus A 2A, B plus C, C plus B is B plus C 2D equals 0, 0. Okay, and if we solve this one, 2A equals 0, 2D equals 0, B plus C equals 0, that gives A equals 0 from this fourth, D equals 0, and B plus C 0, B plus C 0 means B and C are just C equals just negative of B, or B equals negative of C. So all the A that we are trying to determine are A, B, C, D. A is 0, D is 0. Now B, we can just write B, and C is negative B. So the kernel of T is the set of all matrices like this one: 0 B, negative B, 0. Or we can write 0 C or 0 B. Okay, A as the A B. We could have written C, B equals negative C. Okay, same thing. I mean, this one, instead of B equals negative C, we could have written B equals negative C as well. All these matrices such that, I mean, B is in just a real number. Okay, whenever we have a matrix like this one, they will be mapped to 0 matrix by A. Okay, that's the kernel of T. Final.